Modern notebooks, like Jupyter, support rich interactive visualizations using various libraries such as Vega Altair. However, these interactions are often isolated to the visualization, and the results of these interactions aren't usable in the code. Moreover, the interactions are lost on re-executing the cells or restarting the kernel. This hinders adoption of interactive techniques, which can be more suitable for certain tasks, such as filtering outliers, labeling items, or categorizing data points. In this paper, we introduce Persist, a Jupyter Lab extension which adds data manipulations to interactive visualizations and makes them persistent for downstream use in notebooks. Persist captures interactions from interactive components like Vega Altair plots and converts them to operations. Operations are stored in a provenance graph and are applied to the underlying data frames, connecting the interactive visualizations to the actual code. The Persist Jupyter Lab extension supports two types of interactive components: arbitrary Vega Altair charts and an interactive data table for directly manipulating the data frames. Vega Altair charts already can be interactive, but the interactions are lost on rerunning the cell. By wrapping a Vega Altair plot in the Persist chart function, we inject the Persist functionality into the visualization. Persist inserts a toolbar on the top that enables operations such as filtering, categorization, and labeling. Persist also adds a provenance graph visualization on the right of the output with labels describing each action. Analysts can revisit any analysis stage by selecting the corresponding node in the graph. Depending on the interactions, Persist can make smart updates to the output, such as removing the filtered points or encoding the color channel with the newly assigned category field. Persist automatically creates a Python variable which updates based on the current position in the provenance graph. The interactions are preserved in the notebook and can be replayed when the cell is re-executed or after a kernel restart. Persist is compatible with arbitrary Vega Altair charts like scatterplots, bar charts, and other composite charts. The interactive data table supports additional direct manipulation interactions like renaming columns, deleting columns, sorting columns, moving columns, and changing data types for the columns, along with selection and direct editing of individual cells. Now, we will follow an analysis of the Utah avalanche dataset using Persist, where each row records an avalanche. The analysis steps are similar to the task performed in our study to evaluate Persist. First, we use the Persist table function to generate an interactive data table. We notice some column names contain semicolons, likely an artifact of a data import gone wrong. We double-click on the column headers to rename these columns. When we look at the data types for the columns by hovering on the column header, we can see that depth inches is incorrectly typed as a string. We also notice a few rows in the table where there is an entry with a trailing inches symbol, and we use the search function to find other cases like it. We can directly edit the cells to change the text. After removing the errant inch symbols, we change the column type to float using the menu. Now, we will continue the analysis using the process data. Persist maintains a dynamic pandas data frame visible under the cell output in the data frame manager toolbar. Using the buttons next to the dataset name, we can print the first few rows of the data frame to check whether all operations were correctly applied. Using the Persist plot module, we create a Vega Altair scatter plot for elevation versus depth of the avalanches. We identify outliers with elevations below 2,000 feet or above 15,000 feet, which are inconsistent with Utah's elevation range. We select these points using a rectangular brush and remove them using the Remove Selections tool. We will create a new named data frame, No Outliers DF, and use the describe function on the data frame to verify the minimum and maximum values of the elevation column. To analyze avalanche trends over time, we construct a composite Vega Altair plot. It includes a bar chart for avalanche records aggregated by month, alongside a scatter plot. We observe the avalanche season's progression and decide to categorize the dataset into 3 phases: start, middle, and end for the avalanche season. Using the Persist toolbar, we first create a new category, avalanche season, and add options, start, middle, and end. We then assign these categories to the appropriate months. The resulting data frame includes a new avalanche season column, which we verify using the value counts function. Based on this data, we can analyze the variability of avalanche patterns and different seasons in subsequent steps. For an in-depth explanation of the Persist technique and discussion on qualitative and quantitative results of the study, please read our paper.